Here in lessons 34 and 35, what we're basically doing is just taking our trig that we've been learning and putting all those concepts and putting them into word problems. And specifically here in this section, we're going to be looking at solving right triangles. The key with being able to use what all we're talking about today is the fact that you have to have a right triangle. And we kind of drew one here as an example here in the notes. Is basically, if you've got your radius centered here at the origin and you take it out there to a point on the circle, and you're going to have, basically, if you drop down from that point, you're going to create a right triangle. Okay? And if you look here, y'all have all heard of the word SOHCAHTOA before. The SOHCAH and then TOA. Y'all have probably all heard SOHCAHTOA, but what does that refer to? Well, SOHCAHTOA is the technique that you use to solve right triangles. And specifically, how it works is when you have an angle sitting right here inside of your right triangle, if you take the sine of that angle, it's just what it's equivalent to. So the y value at that angle is equivalent to the whole entire side opposite of it over the hypotenuse, the length of hypotenuse. Okay? And specifically, if you wanted to check it out, is that sine of any angle is always, sine refers to our y values, and since our hypotenuse is always 1, that's just showing you right there is just double checking and saying that sine of theta has to equal our y value. Okay? And then cosine is the side adjacent, which is the side touching it right next to it over the hypotenuse, and then tangent is opposite over adjacent. Okay, so we're just going to take these concepts and go to example 1 and just try practicing them. And I'm skipping right away to example 1 just to get starting off, but there's lots of notes in between the very start part and here in example 1 that y'all need to make sure you're reading. Okay, I'm just not going to highlight everything, so I know y'all can read it on your own. So, all right, using the right triangle ratio, that's that whole SOHCAHTOA, we're going to find the missing side or angle requested in these examples. So what I'm first going to do is draw ourselves a right triangle so we can, basically take this information and see a picture for it. So there's my right triangle. And it says side B is 56. Well, it doesn't really matter what we want to make side B. All we can, side B can be either this one over here or it can be the one down below. I'm just going to make it the one on the left just for right now. So that means side C is always reserved for your hypotenuse. Okay. And then obviously down here then would be side A. All right. Other information that we know is that, so that takes care that B is equal to 56. Okay. Now, what we also know is that alpha, so the angle alpha is 39 degrees. So how I point to where alpha is, it's always the side opposite side A. So if this is side A right here, then the little angle opposite that's going to be sitting right up here. And that's alpha, and that's going to equal 39 degrees. Remember, our alphabet letters A, B, and C are going to refer to sides of a triangle. Our Greek letters, alpha, beta, and gamma, are going to refer to angles in a triangle. Okay? And again, sides, what we're looking to do is find the hypotenuse. So if I go up and I'm looking at using the whole SOHCAHTOA, it's like, which one do I use? Oops. Do I go with sine, cosine, or tangent? Well, let's write this out. We only know one angle. The only angle we know is 39 degrees. So the sine of 39 degrees, according to our rules, is the side opposite that. So that's going to be A over the hypotenuse, which is C. Okay. If I do cosine of the angle that I know, then it's going to be cosine says side adjacent. So what's touching that angle is 56. Now the hypotenuse is also touching it, but we're referring that to the H part in the SOHCAHTOA. So then that's C. And then if I go with tangent of 39 degrees, it's always the side opposite of that angle, which is A, over the side adjacent, which is B or 56. Okay? So looking at these three options, which one are we going to want to go with? Well, if I look at the sine option, sine of 39 degrees, look, we don't know A and we don't know C. We want to find C, but we don't know A, so we have two unknowns. I'm going to throw that one out. If I look at cosine 1 or tangent 1, well, both of those, we know cosine of 39. We can plug that in our calculators. This is 56, 56. It's up to you what you're wanting to find. Since we're looking to find C, then we're going to go with this one. If that question gave us all that information and said find A, then we're going to use tangent instead. But we're going to focus on the cosine one, because the cosine one has us find side C. Okay, so cosine of 39 degrees, just remember you always take your sine, cosine, and tangent of an angle, is equal to 56 over c. And the quick, easy way to solve for these, just swap those two around. This is the exact same thing as saying c is equal to 56 over the cosine of 39 degrees. That's just kind of a little cheat sheet, okay? So if we go throughout that, then if we plug this in our calculator, we'll get c to be 75.91. Okay, now remember, it's not degrees because we're looking for the side of a triangle. We're looking specifically for the hypotenuse. And what we want to do is kind of get a little close to we want to pay attention to rounding. I'm not going to be as, critical about it, but I want to pay attention. If I go back to the original problem and the information that was given to us, side B was 56. That's 2 degrees, or 2 significant digits. If I look at alpha, alpha is 39 degrees, which is 2 significant digits. Since both of these are in 2 significant digits, I'm going to give my answer for C in 2 significant digits. So we're just going to say 76. And there's no units, so that'll be our answer for that one. Okay, so as you get practice using SOHCAHTOA, I suggest starting how we started. Give yourself the 3 different options and figure out which one of the 3 are best to fit the situation, and then go from there. Let's try this again with part B. All right, in this example, they're given side A, side B, and we're asked to find an angle. So if you want to draw yourself a right triangle, just to get yourself a picture, we always know that the side opposite of your 90-degree angle is always C, so the hypotenuse is always C. And again, it doesn't really matter which one's A. Maybe I'll start here on the left is A, and then down below is B. Okay, what I do know is the side, or the angle that's opposite side A, that's going to be alpha, and the angle that's opposite side B, which is up there, is going to be beta. So that's going to be right there. Okay. All right, let's write out what we kind of know. And it's always going to be with respect to an angle. So in this case, since we're asked to find beta, I'm going to go sine of beta. Okay, sine is always the side opposite. So if I write the SOHCAHTOA, okay, so it's the side opposite over hypotenuse. Well, what's opposite of beta is 421, and the hypotenuse is C. If I take the cosine of beta is always the side adjacent, so it's sitting there right next to it, which is 621 over hypotenuse, which is C. And then if I go with tangent of beta, tangent is going to be this side opposite over side adjacent. So what's opposite of beta is 421. What's adjacent to beta is 621. So if I go back through these 3 different options, in the first option, I don't know beta and I don't know C. So I'm going to mark that one off. If I go to the second option, I don't know beta and I don't know C, so I'm going to mark that one off. If I go to this third option, the only thing I don't know is beta, and that's what we're asked to find. So we're definitely going to go with tangent. So tangent of beta is 421 over 621. Okay. And anytime I'm asked to solve for an angle, this is when we're going to use our inverse buttons. So those buttons right behind sine, cosine, and tangent, this is where we're going to call these, because what I want to do is get beta by itself. The only way I can get rid of tangent, it's like if you want to pretend like you're dividing off tangent, well, what you do is, you can't really just do that. That's kind of illegal math. What we do is whenever you want to get your trig function off of that side, so you get your angle by itself, you use that tan inverse button. So it's going to be the inverse of that ratio of 421 to 621. So what you're going to do is go in your calculator and just type in, second tan, and then the 421 over 621. And you should get something, by the time we allow just for a little bit of rounding, it looks like it's going to be 34.01386, something like that. Okay, in this case we're looking for an angle. We don't want to sit there and call that, degrees. What we want to do is convert this to degrees minutes. So it's 34 degrees. Remember, all we do to get the minutes is we take this back part and multiply it by 60. So when we do that, then we'll get roughly 34 degrees and 8 minutes. Okay, so there's our answer right there. And if it's pretty much close, if you go back to the original problem, 621's 3 significant digits, 421's 3, and so by the time I rounded it to the nearest minute, we got basically 3 or 4 significant digits right there. Okay, but there's and by the way, make sure, since we're giving our calculators, we're asked to find an angle, that you give your angle in terms of degrees. So if you didn't get that, if you end up getting something like 0.5 or something, it's because your calculator's in radian mode. So make sure it's in degree mode so you can give your answer in terms of degree. All right, let's go on to the next example. What we could do is when you get to examples, like when I say looking at a number, like a number in the book, what we could do is if you want to pause the video and then go and refer, just read through the examples. So that way when I start talking about it, you're not so lost on it. So obviously I'm not going to write out the full example here. But so if you just want to pause it, go pull up number 20 in the book and then come right back here. I'm just going to pick up right here. But basically what example 20 says, or number 20 says, is we want to find the angle of elevation of the sun when a man who is 5.85 feet tall casts a shadow of length 7.13 feet on the ground. So you've got the sun, you've got a man that has a certain height, and you have a length of a shadow. So if you just kind of want to draw yourself a picture, we can call, this up here our wonderful sun. We've got we'll call this the ground right here. And we've got a person just standing right here on the ground. Yay, got feet and everything. Okay. And what we know is that this guy, he is 5.85 feet tall. Okay. And the shadow he cast, we're going to call this right here his shadow. It's a little bit longer than his height. We're going to call the shadow 7.13 feet. Okay. And we'll make that the end of the shadow. What the problem wants us to do is figure out the angle of elevation of the sun. And if you looked back in your notes prior to this, if you read through them before we started this lesson, angle of elevation and angle of depression are always with respect to the horizontal. So if you just focus on looking out and looking up, then the angle from going out to up is your angle of elevation. If you go out and down, so it's like if this is horizontal, if you go horizontal and then look up, that angle created right there, that's elevation. Or if you go from the horizontal and look down, that angle created right there is depression. Okay, so there's elevation and there's depression. And that's what's written before you up in the earlier part of the notes. But it's always with respect to the horizontal. It's very important to know that. Well, if we consider our ground the horizontal, then the angle of elevation's obviously got to be up. So I'm going to call this angle that's created from the horizontal looking up our angle of elevation. And maybe we'll just call that theta. And that's what we're asked to find for this problem. Okay, well obviously we have a right triangle. If we even want to just focus on this small triangle right here, where here is theta, this side's 7.13, and this side's 5.85. Okay? So all we have to do is find theta, and we're good. Well, if this is my right triangle, and this is the hypotenuse, which is C, here's a question. Of our SOHCAHTOA, let's see if we can get a little better at this, and so we don't have to write out all three. Do I need to know side C? Well, not really. C being the hypotenuse, I don't need to know it. What I need to know is this angle right in here. So since I don't need the hypotenuse at all, I really don't have to worry about the SO and the CA, because those both deal with the hypotenuse and I don't need it. So all I need to do is focus on the tangents. Okay. Remember, you always take the tangent of an angle. So tangent of theta, which we're looking to find, is opposite of that angle. So going across that, which is 5.85. divided by the adjacent, which is sitting right next to it, 7.13. And just like the example above, anytime you want to just get the angle by itself, this is when we're going to use our inverse buttons. And making sure we definitely keep our calculators in degree mode, because all of these answers we're going to keep in degrees, nothing in radians whatsoever. So if we make sure your calculator's in degrees, you should get the answer coming out of about roughly 39.368 okay? So obviously our angle is going to be 39 degrees, and then if we take that decimal right there and we multiply it by 60, so that way we can get it into minutes, it's roughly going to come out to be 22 minutes. Now, if I really wanted to get technical, since the 7.13 that was given to us and the 5.85 are in 3 significant digits, well, we could write this as round then the 22 and would round just to 20 minutes. Okay, either one of those really is okay. We can go with either one, but just if you want to get technical, 39 degrees and 20 minutes would be your full answer. But I will take the 22 minutes just as easy. Okay, just make sure you give your answers in terms of degrees and minutes, and don't give me this one right here where it's just decimal degrees. Okay, we definitely want to convert it if we can. Well, let's go on to the next example.